Hello everyone there and welcome to the UNIGIS International webinar. My name is Graham Smith and I'm going to be the moderator for today's session. So thanks very much for coming, and also like to thank today's presenter, Dr. Steve Carver. Steve is a senior lecturer at the University of Leeds and is also the director of the Wildlands Research Institute at Leeds. He has over 25 years of experience in GIS research, most notably in the use of GIS and MCE techniques, as well as his recent work on wilderness. Steve's also the author of one of the most popular introductory textbooks in GIS, which I'm sure many of you will know of. So today, Steve's going to talk about some of his most recent work on mapping wilderness. So I shall pass you over to Steve. And Steve, can you hear me?
Yeah, I can indeed. Can everybody see my screen?
I think everyone should be able to see your screen now, yeah.
Okay, cool. I'll just make it full screen still. Okay.
Sorry, before you start, I think you need to, I don't think you've shown your screen quite right yet.
Oh, right, okay.
You are, it's just taking a while to kick in.
Show my screen, yeah.
Ah, there it is. Brilliant. Thank you.
Excellent. Right. Good. Okay. Thanks for everybody for dropping in. As Graham said, I'm Steve Carver from the University of Leeds School of Geography, also a director of the Wildland Research Institute. Based roughly at Leeds, but it is what I would call a virtual research institute, in that we don't really have a base as such. Rather, it's just a critical mass of people with an interest in wildland, wilderness, rewilding, and other aspects of that kind of research area. What I'd like to speak to you today about, or rather what Graham's asked me to speak about, is some of the work that we've been doing on GIS approaches to mapping wilderness, and I've subtitled that Quantifying the Qualitative. So there's quite a lot here on what I would term the sort of halfway house, if you like, between qualitative and quantitative geographies, and how we can use GIS and some of the more recent methodologies to peel back, if you like, some of the layers and the difficulties of doing that. So here's an outline. Since starting this work, I've kind of gained a bit of a fascination for old maps, and that little bit of Latin there, dracons, translates roughly as here be dragons, and quite often on some of the old global maps, the charts from the Middle Ages and sometimes earlier, you would see this word, this phrase written, and that really just implied, from the cartography perspective, that people in the European world really didn't know what was there, and so there's a bit of a fascination there for the blank spots on the map and what that means for wilderness. I'll then spend a little bit of time just talking about what is wilderness and can we map it, and that obviously naturally takes us into this notion of quantifying the qualitative, because wilderness is, as well as a biophysical reality, if you think about it from terms of nature and ecosystems, then there is this sort of human perspective on it, and it's a concept. Wilderness is a loaded word in many respects. It's a concept which creates some difficulties for us when we're considering both the biophysical and the socio-psychological aspects. I'll then sort of bring us back to reality with a little bit of, well, why should we bother doing this, and look at some of the application areas before finishing off with some thoughts on current work and where to go next. So here's some of these maps. If you look carefully at some of these maps, you'll see the words terra incognita, or parts unknown, or indeed, dracons, here be dragons. And this map's particularly good if you look down at Antarctica. It's obviously the cartographer had some notion that there might be some big landmass there in the Southern Ocean, but it's largely a work of fantasy, and it's inhabited by lots of wild and wonderful animals. There's a unicorn in there, for example, and a lot of the rest of the map is completely made up. Well, Australia and New Zealand had not been discovered, and so there was no notion in the cartographic mind that these continents existed. Here's a more up-to-date one, so a British map from the reign of King George. A little bit more accurate here. They were aware that Australia and New Zealand kind of existed there, but part of it's missing. Part of the Americas are missing as well. There's no Alaska on this map, and the Southern Ocean is in fact labelled very accurately in this instance as parts unknown. That nobody had been down there really and recorded those geographies. I like this one as well. I mean, it's not got anything like parts unknown on it, but it does it smacks of British imperialism. You see Britannia there lording is over her subjects, and all the dominions of the world coloured in red. It's long since no longer applied. Little transgression here. I'm a Pink Floyd nut, and of course every part of the world is mapped and known these days because of satellite technology. This reminded me of a Pink Floyd album called Obscured by Cloud, and it was a soundtrack from a French film called La Vallée about a valley in Papua New Guinea. And on the 1969 map, it just said obscured by cloud, and it was one of the last. The implication was one of the last areas of the globe to actually be mapped and therefore known. And of course, we do have complete world satellite coverage now, and so in many respects, from a philosophical standpoint at least, the whole world is known and therefore might be regarded as somewhat less wild. And we've mapped it in many interesting ways, not just that which is visible, but that is also to some extent invisible in terms of transport routes, air networks, but also nowadays with internet traffic, etc. And this is a good example from the Globia project where these networks are mapped on top of the global map. And I've recently been doing some work with a chap called Benjamin Hennig, who's currently at Oxford University, who's one of Danny Dorling's ex-students, PhD student, who's a very good website, viewsoftheworld.net. And Benjamin and I have been looking at how we can map some of the wilder areas of the world using these gridded cartogram approaches. And there's an example on the screen there of that approach. So what is wilderness? Well, I guess we all intrinsically have a feeling or an understanding of what wild is and what the word wilderness means to us. If we pick apart the word and look at its etymology, that in the English language, wild comes from the early North Teutonic languages, wilderness literally means place of wild beasts. So there's some linkage there to the notion of wild places, which are self-willed, beyond human control, and were the home of some of these fantastic beasts that appeared on some of those early maps. Now, in my career as a geographer, with an interest in the spatial sciences and wilderness, I've been fortunate enough to travel to at least a representative range of these wilderness areas. So we might think, if we're thinking about wilderness, we might think of wild mountain landscapes. This happens to be in Banff Jasper National Park in Canada, but we can think of many examples in Europe as well. I've been to the Arctic on several occasions, here on a ski expedition with my co-author on the introductory textbook, Ian Haywood, to Greenland. I've been to many desert locations such as Death Valley. In fact, one of the I'll come back to this later, but one of the examples of wilderness character mapping, we used Death Valley National Park as a test bed, working in liaison with the US National Park Service and colleagues in Montana. We might think of boreal forests. So again, Banff Jasper National Park example there. There's a Gulf River area. It's a classic boreal forest landscape. We might think of tropical forests as well. I'm not awfully keen on tropical forests because they're too hot and sticky and things want to eat you and sting you and poison you and things. But certainly a wild environment. Don't forget the coasts and marine areas as well. So this is a European example of Calcium Coast, just down the coast from one of their wilderness areas. And the wild beasts. I'm not a very good wildlife photographer, but this is as close as I could possibly like to be to a grizzly bear, but I took this in Yellowstone National Park some years ago. If we want a strict definition of wilderness, then the US Wilderness Act 1964 kind of set the scene for this. It's a bit of a busy slide, but I've highlighted perhaps some of the key phrases in green there. So untrammeled, I know it's a bit of an odd word, but it just means uncontrolled or unmanaged. This notion that humans are visitors, we don't inhabit those areas permanently, we just go visit. Something about ecology there, primeval character and influence without permanent improvements or human habitation. Protected and managed, so to preserve the natural condition, largely affected by the forces of nature, again ecology, imprint of man's work substantially and noticeable, outstanding opportunities for solitude and primitive recreation. So some indication there that these landscapes are valued for particular reasons, for their ecology, for their opportunity for recreation. And finally, there's a size criteria there. The US Wilderness Act said at least 5,000 acres of land, which it goes on to say makes it big enough to actually protect as a wilderness. And a lot of subsequent definitions of wilderness have kind of followed on from that. Yes, okay, it's US and it has a particular US feel to it, but if you look at the recent definition used in European wilderness, you can see exactly where it takes its lead from. If we think, going back to some maps then, one of the early maps of the amount of wilderness remaining in the world was the one produced by Michael McCloskey and Heather Spalding, actually for I think it was the Fourth World Wilderness Congress, and this is the map that they came up with, all done by hand actually. They used the USAF tactical pilotage charts, which then were digitized later on to become digital chart of the world. But they were looking at areas which were of a minimum size, were a certain distance away from the nearest road, no habitation, no agricultural land use. There have been more up-to-date maps produced, a very good one looking at the human footprint, initially to look at the areas where humans have had the greatest impact, but of course the other end of the human footprint index, as it's called here, the green areas stand out as being those which we might be tempted to refer to as wilderness, and this is work by Eric Sanderson and his team at CISIN in Colombia. You could pay it right back to something really simple. I mean, this is a really nice example, the Google roadless areas map. The Crichton census, the Greek MEP was behind this and just said, well, you know, where we have roads, you have potential for human impact on the natural environment. You know, great examples being in rainforest areas where roads are built to provide access for oil exploration, that sort of thing, and as soon as a road goes in, you open up that hinterland for human exploitation, slash and burn agriculture, forestry, timber extraction. And so roads are really really at the base of this kind of notion of wilderness. An extension of that would be Andy Nelson's excellent map on travel time for major cities, some of the world's remotest areas, the centre of the Greenland ice cap, parts of the Himalaya, Siberia, the deserts of Africa and Australasia, and the Amazon rainforest, of course. Let's look at Europe. We've recently just created a map of wilderness in Europe. It was a project that was funded by the European Environment Agency through the EU. A impetus for which was set in motion in 2009 in that the European Parliament passed a resolution on wilderness in Europe with a very strong majority, which recognises that there are still wilderness areas in Europe today, and a number of steps were then taken to map those. As part of that work, we started to tease apart what we considered to be suitable criteria, measurable criteria for qualifying protected areas as wilderness in Europe. So things like they had to have a core zone which measured at least 3,000 hectares with no habitation, no permanent settlements, no infrastructure, so that means no roads, no motorized access, no hands-on habitat management, so natural processes could take place unabated, wildfire control only when needed for public safety, no wildlife management with one or two exceptions for the Nordic countries, no grazing by domestic stock, no extraction of natural resources, the tourism and recreation activities are only allowed if not requiring built infrastructure, so under leave no trace rules. So all of these things are relatively easy to map, and so what we did is we put together maps which were based on remoteness from roads, based on land cover, and comparing those land cover maps from CORINE, the European land cover database, with maps of potential natural vegetation. So that is maps of vegetation that would be there naturally if it wasn't for human influence from urbanization, agriculture, and other infrastructure, and put those together to create this map. Largely using multi-criteria evaluation techniques. So the layers were put together in a simple weighted linear overlay. They weren't weighted, just that's work that we're ongoing at present. So this is the official wilderness continuum map for Europe, and you can follow that through. I've given some references at the end of this talk, which you can use to follow these links through. As you can see, I'm filtering down to smaller and smaller scale here. So we've gone from global maps of wilderness character, wilderness quality rather. We've looked at Europe. Here we're now looking at the UK. This is a map I produced for the JMT, the John Muir Trust, which is a wildland charity that works largely in Scotland but across the rest of the UK as well. And they were very much interested in seeing where the wildest parts of the United Kingdom were, including Northern Ireland, and these are highlighted in blue. Again, very similar methodology. Excuse me. We looked at distance from roads. We used a weighted road density layer, land cover, population density, those sorts of criteria. That kind of led on to a formal mapping process in Scotland. Now, Scotland is a country which has a large portion of its land area which we might describe as wild in one respect or another. We tend not to use the word wilderness in Scotland because it has certain negative cultural connotations which hark back to the period when in between about 1750 and 1850, when a lot of the indigenous population were forcibly evicted from the land by Scottish landowners to make way for large sheep and deer estates. So we tend not to use the word wilderness in Scotland, we tend to talk about wild land. And Scottish Natural Heritage, this is the organisation which looks after, well, as the name suggests, the country's natural heritage. Started a mapping process in 2002. They set out some attributes and some criteria which could be used to identify wildland areas. And we generally split these down. Okay, there's more than 4 there, but we generally boil them down to 4 factors: the perceived naturalness, the lack of obvious human artifacts, rugged or otherwise challenging nature of the terrain, and remoteness or inaccessibility. And again, these are criteria which we can develop spatially. So perceived naturalness, we can look at land cover and associated data to help us determine natural habitats and unmodified catchment systems. In terms of lack of human artifacts, we can look at the absence of buildings and large structures and extensive modification of land use within the area. In terms of rugged and challenging terrain, we can look at topography from digital elevation models, obviously, and in terms of remoteness, we can look at anisotropic models to measure and map distance from mechanized access, so the nearest road, for example. And of course, extent of area. These areas have to be sufficiently large to engender that feeling of remoteness and solitude. To their credit, Scottish Natural Heritage have developed these national maps based largely around methodologies that we developed here at Leeds and the Wildland Research Institute for the 2 national parks. We were contracted in 2008 and 2011 respectively to develop methodologies which ultimately were rolled out across the whole of the country. And this is the draft final map, the phase 1 map as they called it, which is a classic multi-criteria evaluation style map based on remoteness from mechanized access, absence of modern human artifacts, perceived naturalness of the land cover, and the rugged and challenging nature of the terrain. And from that they were able to extract 43 individual core areas across the whole of the country. Most of these are in the northwest and central highlands. A few smaller areas south of what, I don't know if you can see my cursor, but the Highland boundary fault, which demarks the highlands in the north and the west from the lowlands and the south and the east of the country. And going back a little bit in time, this is one of the earlier maps that we developed for one of the national parks, in this instance the Cairngorm National Park. So a wilderness continuum showing, and I apologise if you're a male and you're red-green colourblind, but these were the colour schemes that SNH liked us to use at the time. This green to sort of reddy brown colour ramp, the green area the map being the most wild, and the brown areas of the map being the least wild. And you can see the major roads giving an indication, and the major settlements giving an indication of the distribution of the main human land uses, obviously mainly in the valleys of the area, and the central area being the high mountains. So, what are we trying to do here? We're essentially trying to quantify the qualitative in the wilderness, wildness, naturalness, whatever you want to call it, are essentially human constructs. There's a big literature on this human nature-culture debate. So if you look at the work of Noel Castry and Watmore and other people working in this field, there's this huge debate going on about what is it that we actually mean by nature and wildness. Now, I tend to be a bit of a pragmatist and not awfully interested in the deeper philosophical debates, although I do recognise they exist, but tend to be more of a pragmatist and say, well, okay, let's try and see what we can come up with. Now, for a long time, when I first started doing this mapping work, and I can take that back to an idea I had at a conference in Newcastle, GISRUC, GIS Research UK conference in Newcastle, and I think it would be 1996, about taking my interest in wilderness from a purely recreational perspective, together with my GIS interests, and seeing if I could apply the two together. And for a long time I'd been working on this and thinking, well, okay, the best we can do is probably develop these continuums, if you like, this kind of map here where we have a ramp from most wild to least wild, very much recognizing that everybody's individual perceptions of what is and isn't wilderness can be represented somewhere on that ramp. Where am I going with this? Well, I'm probably saying that it is extremely data dependent. We have a limited amount of data available to us which cover many of these qualitative concepts, and so you inevitably get drawn into developing proxies for things which might be attributes of wildness. So although Scottish Natural Heritage and the US Wilderness Act, they give definitions of what is and isn't wild, and there are hints within those definitions as to geographical or rather spatial indices that we might use, we are inevitably drawn into using proxy measures. And in many respects it's about how do we trade off that which is measurable versus that which is sensed. And everybody is different. People come from different backgrounds, they have different life experiences, different levels of education, different interests, and in wild places they have different responses to the stimulus which they experience of being in those wild places. So mapping that becomes, well, somewhat rather difficult. It's the objective versus the subjective. How do we map that which is a human feeling rather than something which is tangible and fixed on the ground. There are two approaches, like to most mapping, I suppose. That's the top-down versus the bottom-up, and this is a lot of this work that we're doing here is pretty much top-down. You're taking a legal definition of what is wilderness, like the US Wilderness Act, and you're teasing it apart to try to identify the geographical criteria within that and mapping those and coming up with a map. You could alternatively come from the other end, and you can come from the bottom up and let people decide where wild is and isn't wild. And I'll come back to that later on in the conclusions when we're looking at participatory approaches. The other thing which is critical here is this discrete versus fuzzy. Now, going back to that map again, this is a fuzzy map to all intents and purposes, although it's developed using a fairly discrete methodology, although you can apply the weights and other fuzzy techniques, etc., to start to explore variations within that. And as I said, for a long time I was reluctant to take that kind of mapping and actually start top slicing it and saying, okay, here's a top 10% wildland, let's draw a boundary around that and say this is wild and this isn't. Because if you've spent all of your life in a city and never seen real wilderness, then the countryside, urban, peri-urban and rural countryside around the city might seem wild to you. However, if you spent all of your life in a cabin in backcountry Alaska, then it certainly wouldn't. Your experiential level is going to be a lot higher. But recently I've kind of realized that without a line on a map, then we are at danger of losing the very thing that we're seeking to protect with these maps, in that no amount of mapping, fuzzy mapping, no amount of heartfelt pleas and erudite descriptions are going to protect wilderness from development in the eyes of planners and decision makers and lawyers and developers, etc. You've actually got to put a hard line on a map and saying this is the wild, keep out, or this is the wild, let's manage it carefully. So anyway, we'll come back to putting lines on a map in a minute. And yes, it is rather complicated, but as that old adage says, KISS, keep it simple, stupid. In many respects, we walk a difficult line between overcomplicating things and oversimplifying things. I'll give you some examples now, because I'm very well aware that I'm talking to a bunch of GIS geeks, and you probably want to see some methods and other things. So just before I conclude this, just give you some examples of what we've done here. Let's take remoteness first, and then absence of modern human artifacts as just two examples. In terms of remoteness, you could just use linear distance from the nearest road, but that's somehow missing the point, in that a lot of these wild areas are in areas of mountainous terrain, or they're coastal areas with difficulties of access. So inevitably you have to use anisotropic distance models. And in Scotland we've used Naismith's rule, which is a Walker's rule developed by a guy called Eric Naismith in 1892. A number of times I've referenced the 1892 paper in journal articles, and editors have said, don't you mean 1980? No, it is actually 1892. And that rule just basically says you can walk 3 miles an hour on the flat, and you add half an hour for every 1,000 feet of climbing. And of course for that you've got to know your terrain models and other things. And then the other thing I'll just briefly talk about is absence of modern human artifacts and the visibility of obvious human features. And here we had to develop our own software, which I hope to be able to demonstrate to you in the next few slides. So remoteness first, it's just, these are the criteria from SNH. We're talking about distance from settlements, limited accessibility, and it does recognize that distance is not an absolute guide on its own. It's really about how long it takes you to walk in. And that's a thing in Scotland. People often talk about the long walk in when we're talking about climbing mountains in Scotland. And there is this spot of Munro bagging in Scotland. Munro is a mountain over 3,000 feet in altitude. And a lot of these mountains are in very remote locations, and you have to walk a long way before you even start to climb the thing. These kinds of landscapes. So this actually wasn't a Munro that we're up on the top of here. This is Morven, and I believe it's a Corbett, which is a different type of mountain. But these slides give you an impression of the kind of landscape. Some of it's very difficult terrain to cross. So in the foreground here you have a very boggy pool and hummock community, which is incredibly difficult to cross. And here we are, sort of a long walk into Morven in the background. You have barrier features to take into account, so there are many lochs in Scotland. The snow in the background presents its own difficulties, or indeed opportunities if you're a skier, and differences in vegetation as well. We might want to take into account local access features. So although this is a stream which could easily be crossed at the time by jumping from rock to rock, in the winter months when it's a raging torrent you definitely need the bridge, and therefore the river creates a barrier feature which can be crossed only at discrete locations. And this gentleman on the skis in the foreground, some of you may recognise, that is Dr. Ian Hayward. And again, different types of travel can be modelled in this way. So cross-country skiing, alpine skiing, mountain biking, walking, horse riding, etc. Those non-motorised modes of transport, including watercraft. And we've done some modelling of this as well around the coasts and lochs of Scotland. And localised are limited road networks and the need to use ferries as well. Version 1 of the remoteness map produced by SNH was simply using buffers but with barrier features included. And this is from the 2002 document on wildness in Scotland's countryside, where they were mapping distance from roads, public roads, and distance from public and private roads. And as you can see, you add in the private roads, of which there are quite a lot on the estates, the deer stalking estates of Scotland, and it rapidly reduces the area greater than 8 kilometres from the nearest track. Version 2 of that map took Naismith's rule on board, and we modelled Naismith's rule using terrain, using land cover and barrier features, and taking those into account. The map on the left is for the whole of Scotland. The map on the right is for the Loch Lomond and the Trossachs National Park, which is located around this area of Scotland here, as opposed to the Cairngorm, which is up here. And we modelled both winter and summer conditions, so going back to the notion that local access features, bridges over major rivers, can provide discrete points of access in the winter. So we modelled under low flow and spate conditions, and you can, flipping between the two maps, you can see that those do play an important role. And indeed, some of these sharp lines on the maps where rivers without bridges create barriers, features to travel. Going on then to absence of modern human artifacts. This is all about landscape really, the quintessentially visual. It's a combination of natural and human features, and in Scotland we were interested in mapping those areas where there is a lack of human activities or features which are visible. Now, any of you who've done visibility analysis will know that it's very computationally intensive and potentially extremely slow, especially when you want to map what's visible from every 50-metre grid cell across the whole country and work out what is and isn't visible. And we included in this features at a point, including buildings and structures. And that does include the very large structures, such as wind turbines, as well as very small structures, such as individual buildings. Also linear features, such as roads, tracks, power lines, railway lines, etc. And the blocky features, the human features, such as, like in this central photograph here, you have large, in this photograph here you can see areas of plantation, non-native plantation forest. The stuff we didn't consider was that which is too small to appear on the baseline mapping, and also the ancient monuments and cultural remains. It's about what you can see from where. So we had to use visibility analysis together with a terrain model, and we included terrain surface features as an offset, a vertical offset, so buildings and trees, when you're stood up close to them, can block the view, so we have to take that into account. And here we're trying to calculate the lack of, or the number of human artifacts in the landscape. And that brings in a whole series of issues. A, the accuracy of the terrain model and surface features, of course, and your atmospheric effects and distance decay. But the principal one is that it's computationally intensive. As I say, if you've ever tried to do dense cumulative viewshed analysis using packages like ArcGIS or QGIS or Saga, you'll know that it takes a very, very long time. And if you're doing millions of viewshed calculations, then you've got problems. We had to develop our own software to do this. Here's an example for Loch Lomond. So we got roads and tracks and railways. The non-visible areas are in this kind of eau de nil colour. So these are the areas you cannot see: roads, tracks and railways, plantation forest, buildings and structures, pylons, cables, reservoir, drawdown lines, etc. And you're able to combine those together to produce combined viewshed. We also included wind turbines. Here we have to include over a much larger search radius because they are very big features visible from very large distances. So this is existing in turbines, those which have been approved in the planning process, those which are in the application stage, and those in the scoping phase. And we're again able to add those in so that we can see actually quite a small amount of difference by adding in the wind turbine. Now the way that we were able to do this is we had to develop our own software, and this is where, fingers crossed, this will work. I'm going to load 2 bits of software. The first is just a demo. It's an animation, so I'm actually going to load some real data here, and this is the Cairngorm. You might recognize the outline, and I'm going to move my cursor over that map, and this is the viewshed that you're seeing in blue. So this is not pre-cooked or you know, done all. It's not a database it's accessing. This is calculating on the fly, and you can see it's pretty rapid. We can also set minimum and maximum distances. So if I move to the side, we'll just so I've changed those minimum and maximum distances, search distances. And we can put distance decay functions in, so you can see the extremities of the viewshed. It's now in a green color ramp, showing how the distance decay affects how visible objects are. A linear gives us apparent height of the object, square gives us apparent area. What I also do is just show you the batch version of this software, which allows you to load a whole series of features that we're interested in, roads, railways, buildings, etc., with the terrain model, and calculate the cumulative viewshed over the whole area. I'll just get rid of that. That was a horrible thing that we programmed in for the Scottish, for Loch Lomond Trossachs National Park. I'm just going to load a DEM now, and I'm going to do a DEM of the whole of Scotland, and I'm going to put in some feature data. Now this is a map of perceived naturalness. And because it's the whole of Scotland at 100-metre resolution, this is more than will fit in the memory of my machine, so we have to tile it. And so we have this tool for tiling, which I think is rather cool because it just looks like tartan. And this, the overlap, if you like, is the viewshed search radius. And I'll set that at 100 cells if I can. So 100 meters, 100 cells is 10 kilometers. And I'll choose an area that I want to calculate the viewshed for, the cumulative viewshed. Now it's loading that into the computer's internal memory. I'm just going to maximize that. And you can see the animation. I can move my cursor up and down the coastal area and then into the inland, and you can see the viewshed being calculated. But if I want to calculate a cumulative viewshed at every single grid cell intersection, then I need to set this going as a batch job. And so I can click Do Transform, gives me a little warning and say this could take some time, and I'll click OK. Now, because this is it's actually a very fast machine I'm using. It's I'll not bore you with the details, but it's a fast gaming machine. You can see it's calculating nearly 1,000 cells a second, and the time left to do this particular tile is about 5 minutes. If I'll just do that because it was hidden behind the icons there. You can see the progress going, and these are the features which it's calculating the visibility for, and we can display those separately. Now, I'll just go back to my slides. So this is the Viewshed Explorer. Briefly, it's based on first-person shooter gaming technology, algorithms, raycasting techniques, and of course those gaming software, they have to work in real time, otherwise the games don't work, they don't make sense. So when you're running around shooting at your opponents, whether they're aliens or soldiers or whatever, it's got to work real time, and it has to be fast. So we borrowed that technology and applied, it's essentially the same idea, line of sight to the calculating viewsheds. Okay, I'll leave that running, and I'll conclude, and I'll show you the results in a minute. So protecting, why bother? Well, to map is to know. So we've gone from those terra incognita maps of global digital spatial data. And I've talked about hard boundaries for fuzzy concepts and why we need those, and why we might be interested in improving wildland quality and character. And a buzzword at the moment, of course, is ecosystem services. And I would countenance that we would get, in total, more ecosystem services from, or better quality ecosystem services from wilder landscapes than we would from modified landscapes. Take water quality, for example. Clean water you get from protected catchments, wildland catchments, wilderness areas. If there's lots of urban and industry in a catchment, yeah, don't drink the water. And something recently which is becoming very popular is this notion of rewilding, so making space for more nature, so we can use these maps to identify areas which might be possible to pull back a little bit of human development from and create wilder spaces. Or not. That's just a wordle, just showing some of the words which are coming out of the literature. Going back to the viewshed stuff, I developed an animation of wind turbines. So renewable energy is important. We need to reduce our carbon footprint, but it's a trade-off. This is potentially a green-on-green impact in terms of Scotland. A lot of wind turbines are having a great degree of impact in terms of the visual quality of those wild landscapes. You see this animation running up to 2015 of the visibility of wind farms across the whole of Scotland. And these are some images from a paper which is currently in press, looking at the areas, in this instance, the light blue areas are non-visible areas where you cannot see wind turbines from currently. And if we incorporate the wildland areas from the S&H national map, where could you build new turbines such that you weren't physically or visually impacting on those areas? And just to conclude, where are we going and what are we doing next? Well, the European national level mapping proceeds at a national level, so we're about to start work with the IGN in France, doing some new visualizations with Ben Hennick at Oxford University. The wilderness character mapping is continuing in the States. We're also using the wilderness quality maps as baseline data for habitat connectivity, looking at calibration for species reintroductions, etc. And finally, that thing about, well, we can use participatory GIS as a bottom-up approach to really validate or calibrate some of these maps. And so that's some of the work we're doing there. And there's some further reading, so I shall see if that map's finished. Almost there, a couple of seconds left. And there we go. If anybody's interested in using this software, do let me know. And I'll be quiet now and ask if there's any questions.
Okay, thank you very much, Steve. Thank you. That's great. I do actually have some questions that I can ask you from the audience. First one's from Eddie, and it basically was really interested in the idea that the wilderness, or some people required wilderness to be defined as a hard line on the map. I was wondering if you had any negative criticisms of this top-down approach from historians and social scientists.
Lots. When I first produced some of these maps at a conference in Scotland, I did accidentally use the word wilderness and almost got shouted down. But yes, you can, as I say, if you're in a room full of people and you ask them where their wilderness begins and ends, you probably have as many different maps as you have people in the room. And this is one of the great advantages of a multi-criteria approach, in that you can ask people how they wish to, what factors or criteria they wish to include, how they want to weight those, how they want to combine them, so that they can produce almost a unique, customized map for them, for their perspective. It's still pretty much top-down, and you're using the data and their opinions to define the mapping, or you can come from the bottom up and use participatory GIS approaches, where you're actually getting people to mark on the map, either using drawing polygons, or using a fuzzy spray can approach to mark on the map. And in this web link here, MapMe is just one such approach, where we're using fuzzy spray can tools to try and identify where people think wilderness is and isn't.
Brilliant, thanks Steve. Gina's asking about, have any of these maps been used in policy or in actual practice as yet?
Yeah, absolutely. Again, I don't know if you can still see my slides on the screen, but this link on the last slide, the SNH wildland map pages, you know, I started playing around with these maps in '96. The 2002 policy statement was just that. It was a policy statement from SNH. And then they contracted us to develop the methodology in 2008, 2011 with the national parks. They then took that methodology and used it themselves. They kept us on as technical advice and assistance, and those maps then became policy, if you like. So in 2014, they finalised their mapping. In 2015, the Scottish Government produced two documents, the National Planning Framework 3 and the Scottish Planning Policy Guidelines, in which wildland was embedded within that, and the maps were in there as well to inform those policies. So yes, it is policy in Scotland. It's developing policy in Europe. It's policy in the US. So our wilderness character mapping has been used to underpin. Well, really, I mean, the US Wilderness Act, 1964, it didn't do anything about mapping, but you know, we've since worked with the US government to use these mapping technologies to provide a spatial realization of the '64 Wilderness Act. I never really thought of it like that. So yeah, thanks for that question.
Thanks, Steve. Jean's got another question actually about what's missing from the maps. Is there anything that cannot be represented by GIS? And to be honest, this links into a question I personally was going to ask you, and that was about, you mentioned about the socio-psychological factors, and what I was thinking about was non-representational theory and things like affect. And I'm wondering, are these the things that you still can't quite get into the mapping process, or how far are you going on with that?
I mean, both ends of the spectrum. The one thing that we don't really have sufficient information on is, you know, ecosystem function. We can map species distributions, but in many respects we still don't have good enough data to say that this is a fully functioning natural ecosystem. We can map human impact on that, so this concept of heteromoby. We can map potential natural vegetation patterns, but we don't have sufficiently high quality detailed data on ecosystem function. The other end of the spectrum that you mentioned there is, yes, I mean, it's we don't have sufficient information on, you know, individual responses. Now this is where it's an area I'd love to get into, and something I've been talking about with colleagues is about you know, psychogeographies, in that you know, different people will respond to the wilderness condition and stimuli in different ways, and it'd be really nice to be able to get some level of a handle on that, either using, you know, sort of wearable technology or something. I don't know. We're trying to tease out some of those things through the bottom up, you know, fuzzy mapping, spray can, public participation, GIS approaches. But yeah, two ends of the spectrum, which really like to try and get some better data on.
Brilliant, thanks, Steve. I've got another quick question. Just looking at the Scottish data, in particular, the Scottish wildlands, you know, when you're looking at this idea of distance and remoteness, it seems that the idea of the vertical aspect is so important. Is that purely, you think, the case for a lot of the developed sort of nations of the world? Because I'm guessing some other areas, wildland or wilderness, topography isn't quite as important in that sense? Is it purely just a Scottish or European or developed region phenomena? This idea of topography and its
Yeah,
impact.
interesting question. Certainly, if you look at, again, I hope you can see the slide still on my screen.
Yeah.
If you look at the European Wilderness Indicator, which is based on land use and population and remoteness, what you see there is a very striking latitudinal and altitudinal pattern. Now, you mentioned altitude, then the areas like the Alps and the Pyrenees and the mountains of Scotland and what have you coming out very strongly. But there's also this very strong latitudinal pattern. So it's the frozen north which comes out very strongly in this map of wilderness quality across Europe. But then there's yes, so there are multiple things going on here, and I guess it comes down to how topography and climate have impacted or have allowed certain landscapes to become the basis of human civilizations. So that which is easily settled and farmed and made productive has become highly modified by human activity. Those landscapes which offer little in terms of natural resources, principally from agriculture, forestry, or are difficult to access, have remained wild, and that's true across the rest of the world. We did do some work looking at spatial patterns of biodiversity and wilderness a few years ago and found strong correlations with climate at a global level. So landscapes which are hot and dry or cold and dry tend to be wild, and those which are very moist and warm tend to be high biodiversity. And there's a middle ground. The relationship holds true in the middle scales, the regional scale, but it falls apart in terms of wilderness and biodiversity at either end of the spatial spectrum.
Great, thanks, Steve. Just a couple more questions, if I may. Eddie's asking about the DEMs. You mentioned it was a 100-meter DEM for the one that you did on the fly for us.
Yeah.
Are these Ordnance Survey DEMs, or can we use any input DEMs in this software?
You can use any. I mean, the software imports the DEM as a floating point grid, so you just got to convert whatever your DEM format is to a floating point. So you probably saw when I was selecting the data that there was a header file and an FLT file. So that's all you need to do. What the software is actually doing is working out what proportion of the viewshed is taken up by the input features. So your input features also need to be placed in a floating point grid.
Brilliant. You mentioned about this software. Is this freely available, or is it maybe available on request if someone was interested in doing a bit of research, maybe for a master's project or something else, they could contact you?
Yep, absolutely. If it's for research only, we can load the software out if you like. If it's a commercial or a government application, then we have a licensing structure for the voxel viewshed tool. So at the moment it's licensed to the 2 national parks in Scotland. The Scottish Government have got a license. The US National Park Service have a license as well. So those are our current customers.
Great.
Yeah.
Thanks, Steve. And James is asking about the MCE methods, and how do you think, I guess this may be a slightly different question, how do you think big data is going to affect the development of MCE methods? So a slightly different tact, but see what you think of that.
Question, yeah, I mean one of the drawbacks, or the positives, if you think about it in terms of big data of multi-criteria techniques, is that they are incredibly sensitive to the weights that you use. Now, with the wilderness stuff, I didn't put any of these maps in, but I have at various conferences, handed out questionnaires asking people to select and weight their criteria. And as I say, you have as many different maps as you have in people in the room, but if you collect lots and lots of maps, you can create composite maps which are consensus maps, if you like. Now, big data could play into that, and if we can pull out of these big data sets sufficient information from as many people as possible about their wishes and wants and perceptions of the relative importance of different aspects of wilderness or any other topic that we care to talk about, then we can develop more and more robust mapping solutions.
Great, thanks very much, Steve. I think that's all we've got time for today. There was one question about a copy of the slides, but this has been recorded, and so we'll make, Steve's agreed that this presentation can be made available, and so it'll go on the web pretty soon. So
yeah, okay.
I just like, sorry,
if anybody had difficulty finding any of these references, just email me.
Okay, that's brilliant. Thanks very much, Steve. Great talk, really interesting, and lots of interesting questions. So I'd like to thank you for your time and to thank the audience for participating. So thanks very much. That's it for today. Bye now.
Okay, thank you everyone. Cheers, bye.